Good students, and in this clip we're going to be going over two examples using our right angle trigonometry. So let's go ahead and write down the first example. For number one, we asked to do the following. So for number one, for the indicated angle, theta, find the value of all six trig functions, okay? All right, so in this problem, we have the triangle with the following orientation, a triangle like this. This is theta, and this side measures 8, and this side right here measures 6. Okay? All right. So if we are to find all six trig ratios, we need to find the sine, cosine, tangent, and their reciprocal trig functions, cosecant, secant, and cotangent. So in order to do that, we're going to have to use SOHCAHTOA. Okay? All right. But in order to use SOHCAHTOA, we need the opposite, adjacent, and hypotenuse. So where is the opposite, adjacent, and hypotenuse here? So let's label our triangle. If this is a reference angle, this is the 90-degree angle. Let's indicate that. That means that the side opposite the reference angle is your opposite. Okay? That goes your opposite. That's O. This side that measures 6 right here, this other leg of the right triangle is your adjacent. And the side opposite the biggest angle in the triangle, namely the 90-degree angle, is your hypotenuse. Okay? So this is O, and this is A, and this is H. So like I said earlier, we need O, A, and H to find all six trig ratios. We have only O and A, so we need to find H. Okay? So we know from the Pythagorean theorem that A squared plus B squared equals C squared. But we're going to use a different variation in this case. Okay? We're going to call the legs O and A. So let's call this A and call this B. And then the hypotenuse is always C. Remember, it doesn't matter what you call A or B, but the longest side is always C. So plugging that in here, our new formula that we're going to be using for trig is adjacent square plus opposite square equals hypotenuse square. Okay? Now we're looking for the hypotenuse because we know that the opposite is 8 and the adjacent is 6. So we're going to put in these two values into a triangle, into this equation, our new Pythagorean theorem, and then find out what they are. Okay? All right, so we have A squared is going to be 6 squared plus O squared is going to be 8 squared equals H squared. We don't know what H is, all right? 6 squared is 36 plus 8 squared is 64 equals H squared. Using the reflexive property of equality, we have H squared equals 36 plus 64 is 100. If you take the square root of both sides, we know that H is 10. So our hypotenuse is 10. Okay? So now we're good to go. We know O, A, and H. Now we can figure out all six trig ratios. So sine of the reference angle theta is opposite of a hypotenuse. How did I know that? From SO. So tells me that sine is opposite divided by hypotenuse. Opposite is 8. Hypotenuse is 10. We can reduce this by dividing top and bottom by 2. We divide by 2 and divide by 2. So that's going to become 4 over 5. All right. Now, for reciprocal trig function cosecant, if I reciprocate sine, I get cosecant. That's going to be hypotenuse over opposite, which is 10 over 8. But when I reduce it, I'll get 5 over 4. All right. Now, cosine. What is cosine theta? From Ka, I know that cosine is adjacent to the hypotenuse. So cosine theta, this theta right here, is adjacent divided by hypotenuse. My adjacent is 6 divided by my hypotenuse, which is 10. I can reduce that by dividing numerator and denominator by 2. Divide by 2, divided by 2, and that's going to yield 3 over 5 for my cosine. The reciprocal of cosine is secant theta. So to get secant theta, I would reciprocate this ratio to get hypotenuse over adjacent. And that's basically going to be 5 over 3. All right? The last two are tan and cotangent. Tan, we can get from looking at the last three letters of SOHCAHTOA, which is tan equals opposite over adjacent. The tan theta is going to be O over A, opposite over adjacent. My opposite is 8, and my adjacent is 6. I can reduce that by dividing top and bottom by 2. Divide the numerator by 2 and the denominator by 2. That's going to yield 4 over 3. If I reciprocate that, I get cotangent. Cotangent theta is adjacent over opposite, which is the same thing as 3 over 4. Okay? So there goes our 6 trig ratios. Now let me organize them together in a list here. So sine theta is 4 over 5. Its reciprocal cosecant theta is 5 over 4. Cosine theta is 3 over 5. Its reciprocal secant theta is 5 over 3. Tan theta is 4 over 3. And its reciprocal cotangent is 3 over 4. Okay, so there goes all your 6 trig ratios. Okay? All right. Now moving along to number 2. All right, so for number 2, let's consider the following problem. For number 2, if sine theta equals 5 over 6, find the value of all the other 5 trig functions. Okay? All right, so if sine is 5 over 6, what does this tell us? Well, since it's sine, we're going to write SOHCAHTOA. SOHCAHTOA. SOHCAHTOA tells us that sine is what? It tells us that sine is opposite of a hypotenuse. So what does this mean? That means that this numerator is your opposite, and the denominator is your hypotenuse. So what we have to do is construct a triangle in assign the opposite the measure of 5 and the hypotenuse the measure of 6. That will enable us to find the adjacent, and then we can find all the other 5 trig ratios. Okay, so let's go ahead and construct a triangle. It doesn't really matter the orientation of our triangle, but it must be a right triangle. So there you have it. Remember, SOHCAHTOA applies only to right triangles. Now we have to indicate a reference angle. Let's call this theta. Okay. Now, if this is theta, that means that the side opposite this angle is your opposite. All right, opposite. And now we know that the opposite, based on this information, is 5. So our opposite is 5. All right, what else do we know? This is a 90-degree angle. So the longest side is the hypotenuse, right? So the longest side is the side opposite of 90 degrees. That's always the hypotenuse, and I know that that side measures 6 units. Okay, so that's 6. How about this side? This is known as the adjacent, right? What does the adjacent measure? We don't know yet. So in order to find out what the adjacent is, we're going to use that new variation of Pythagorean theorem I just introduced earlier to find what A is. Okay, so I know A squared plus B squared equals C squared, but in this case, we're going to use A squared adjacent square plus opposite square. These are the legs, always equal to the hypotenuse square. Just like A squared plus B squared equals C squared, A squared plus O squared, the legs, the square of the sum of the legs equals the square of the hypotenuse. Alright? So let's use this to find out what A is. A squared remains A squared since we don't know what A is. O is 5 squared equals A squared, which is 6 squared. Okay? Alright, so let's work this out. We have A squared plus 25 equals 36. Next we're going to do to get a by itself, we'll subtract 25 from both sides and take the square root, okay? So subtract 25, that leaves us with a squared equals 11, and then you take the square root of both sides, and then we have a, the adjacent, equals the square root of 11, all right? So over here, we're just going to put in square root of 11 as the adjacent. Okay, now we're ready to find all 6 trig ratios. So using SOHCAHTOA, let me just write SOHCAHTOA here again for easy reference. From SOHCAHTOA, I already have sine, right? I know that sine theta is opposite over adjacent, opposite over hypotenuse, which is 5 over 6. Okay, the reciprocal trig ratio cosecant theta is hypotenuse over opposite, which is 6 over 5. Alright? Next is the cosine portion. Cosine theta is adjacent over hypotenuse from cap. And that tells me that the adjacent is root 11 divided by the hypotenuse, which is 6. Okay? Now, from that I can determine my secant. Secant theta is hypotenuse over adjacent, which is 6 over root 11. Okay, just reciprocate this, okay? Well, we cannot have a square root in the denominator, so we have to rationalize the denominator. So multiply by root 11, top and bottom. And that gives me 6 root 11 over root 11 times root 11 is simply 11, because the square roots cancel out. Or you basically have the square root of 11 square, the square root and the square inverses, they cancel out to get 11. Okay? So root 11 times root 11 in the denominator is just 11. So there goes your secant. Next thing we need is tan. Alright, so tan theta is what? From TOA, tan theta is opposite over adjacent, right? So our opposite is 5 and our adjacent is root 11, so it's going to be 5 over root 11. Okay? So now to finish this up, we need to get rid of the square root in the denominator, so we need to rationalize, multiply by root 11 top and bottom. So this gives me 5 root 11 over 11 for my tan, because root 11 times root 11 is 11 as we discussed here. The reciprocal cotangent theta is reciprocal of opposite over adjacent, which is adjacent over opposite. Okay? Alright, it's adjacent over opposite, so let's go ahead and figure that out. Adjacent over opposite is simply going to be root 11 over 5. Okay? So let's organize all our answers together in a nice little matrix here. So sine theta is 5 over 6. The reciprocal cosecant theta is 6 over 5. Cosine theta is root 11 over 6. Its reciprocal secant is 6 root 11 over 11. Tan theta is 5 root 11 over 11. And its reciprocal cotangent is root 11 over 5. So there goes all our 6 trig ratios, nicely organized. Okay? So there you have it. So thanks so much for taking the time to watch this video. Please feel free to subscribe to my channel just by clicking here for other cool clips such as this. More videos can be found on mathwithsir.com. Thanks again and have a wonderful day.